Welcome to the first derivative test. So I'm going to go ahead and state the theorem, and then we'll deal with the interpretation after. So the theorem is if, well, I'm going to switch colors one moment. If f is differentiable on interval I, containing critical value C, that my screen froze for a little moment. Let's see if it'll work now. So f is differentiable on interval I, which contains the critical value C. Then we have sort of three different situations to work with. If f prime switches from positive to negative, at x equals c, then there is a relative maximum at x equals c. Let me give myself a little more space. Next up, if f prime switches from negative to positive at x equals c, then there is a relative minimum at x equals c. And then the only other case would be is if f prime does not switch signs. So if f prime does not switch signs, at x equals c, then there is no relative extrema at x equals c. So essentially what this theorem is saying is if we have our, do the situation we were dealing with before, here is C. So this is our X values and our F prime. We have our critical value at C. So maybe F prime is equal to 0, or maybe it's undefined. If we switch from positive to negative, well, we know that that means that F, positive F is going up, flattens out, and goes back down. Then this means basically that our graph would look at least near C like this. So at least near C, this is what our graph of F would look like. And so we have a relative maximum. if we have the next case, so C, F prime switches from negative to positive. Well, if F prime is negative, that means F is decreasing, so we're going down, then it flattens out, and then it goes back up when it's increasing. So as the graph, we start off going down, turn around to x equals c, and then head back up. So we have a relative minimum. And then if we don't change signs, so for example, if we stay positive on both sides, start positive and stay positive. So if we're positive and positive on both sides, that means that we're going up, we flatten out, and then we go up some more. So in this case, our graph will look like maybe we go up, flatten, and then up again. And so this is not a relative max or a relative min. It's just sort of a place where we level off briefly. We will actually call this point a point of inflection. Which we will talk about much more in section 3.4. Similarly, if we have negative and negative, the graph starts off going down, levels off, and then continues to go down again. So if we look at what this means in terms of the graph, we start off decreasing, level off, and then decrease some more. So once again, this is not a relative max or min. And we call that a point of inflection. So this is essentially the situation we're in. The reason I draw our number lines and I like to draw these little arrows is it essentially shows us precisely what the graph will look like if we smooth things out. So again, you can kind of see the relationship between what I drew with my arrows over on the left, right, versus how I graphed over here. It's a smoothed out version of my arrows. So essentially, this little diagram I draw is to help me visualize what the graph looks like.